All right, let's jump right in. We're about to pull back the curtain on a piece of technology that's so fundamental to your daily life, you probably don't even know it's there.
Seriously, think about it. The app you use for banking, the social media you scroll through, booking a flight, shopping online, pretty much all of it runs on a core concept that's half a century old. It is the absolute bedrock of our digital world.
Well, it didn't just pop into existence. It was actually born from a whole lot of chaos, a ton of frustration, and one incredible flash of mathematical genius. And that's the story we're going to dig into today.
So, to really get why this was such a revolution, you gotta understand what the world was like before it. We're in the 1960s, right? And computing is making this huge leap from clunky magnetic tapes to these new things called direct access storage disks. For the very first time, you could just jump straight to a piece of data. This created a brand new problem. How do you manage all that information? You needed a database.
Okay, so what did the first engineers come up with? Well, they built some really clever stuff, but man, was it complicated. Let's meet the folks who took the first crack at it.
So the first big name you need to know is Charles Bachman. He was at General Electric, and he created something called the Integrated Data Store, or IDS. His goal was to manage all the moving parts in their manufacturing systems, and what he built was a true breakthrough. It was the world's first database management system. It was so important, it won him computing's highest honor, the Turing Award.
At the time, there were basically two competing schools of thought. On one side, you had Bachman's idea, which we call the network model. Imagine a giant, messy spider's web. Every piece of data could be connected to any other piece of data with these direct links called pointers. Super powerful, but a total nightmare to navigate. Then, on the other side, you had the hierarchical model. This was way more structured, kind of like a strict family tree. Data had parents and children. It was neat, but oh so rigid. If you needed a piece of info way down at the bottom of the tree, you had to start at the top and climb all the way down step by step.
And the undisputed king of that hierarchical model was IBM. Their system, IMS, was an absolute beast. I mean, it was built with NASA to keep track of the thousands upon thousands of parts for the Saturn V rocket, the thing that literally took us to the moon. But for all that power, it was still stuck with that core inflexibility. So that was the state of play. Powerful, but really, really difficult.
And this is where our main character walks on stage. His name was Edgar Codd, a researcher at IBM. And he looked out at this landscape of messy webs and rigid trees and thought, no, there has to be a better way, a more logical way.
You see, Codd was a mathematician. He saw systems that were physically tangled up with the hardware they ran on. To get data, you had to be this expert navigator who knew exactly where everything was stored. He just felt the whole field was missing a solid scientific foundation. He wanted to bring the clean, beautiful logic of mathematics to this messy world of data.
So, in 1970, he published a paper that would change everything. The idea at its heart was just breathtakingly simple. He said, forget the webs, forget the trees, just put your data in simple tables. That's it. He called these tables relations.
So how does it actually work? It's beautiful. Step 1, all your data just lives in these simple tables, kind of like spreadsheets. Step 2, every single row in a table gets its own unique ID, what we call a primary key. And step 3, this is the magic part, you connect tables just by referring to those keys. No more physical pointers telling the computer where to look on the disk. The relationships were now logical, not physical.
And that was the whole ballgame. Codd separated the logical model, how you, the programmer, think about the data in neat tables, from the physical model, which is where the bits and bytes actually live on a disk. All of a sudden, programmers didn't have to be hardware experts anymore. They could just ask for what they wanted and let the database itself figure out the fastest way to get it. A total game changer.
An idea this big couldn't just stay on paper, right? Codd's paper basically lit a fuse, and it kicked off this mad dash to turn his elegant theory into a real working product.
But here's the crazy twist in the story. The biggest obstacle to Codd's idea was his own employer, IBM. I mean, they had poured a fortune into IMS, that hierarchical database we talked about. It was a cash cow.
They were terrified of disrupting their own business, even for a revolutionary idea that came from inside their own walls. Now, eventually, IBM's own customers started hearing about Codd's paper and putting on the pressure, so Big Blue finally relented. In 1973, they kicked off a research project called System R. But they weren't alone. Over at UC Berkeley, a professor named Michael Stonebraker started a project called Ingres, and then a programmer named Larry Ellison read Codd's paper and decided he was just going to build a commercial version from scratch. That little company would soon be known as Oracle.
10 years. Let that sink in for a second. That's how long it took from when IBM started their research project until they actually sold a commercial product. A full decade.
And you can see how it all played out right here. That decade-long delay created this massive window of opportunity. While IBM was carefully researching, Larry Ellison was building and selling. In 1979, his company shipped the very first commercial relational database. They beat the inventors of the idea to their own market by 4 years. Oracle grabbed that opportunity and, well, they never let go.
So, it sounds like IBM just lost the race. Plain and simple. But the story's actually a bit more complicated than that, because the work done during that frantic race by all three of those teams built the foundation for literally everything we use today.
Here's the incredible irony. Even though IBM was slow to market, their System R research team invented two technologies that are absolutely essential today. The first was SQL, the structured query language. It's the standard, universal language we all use to talk to databases. The second was cost-based optimization. That's the brain inside the database that brilliantly figures out the fastest, most efficient way to answer your questions.
And when you look at the family tree of databases today, the impact of this era is just crystal clear. Pretty much every major relational database you can name can trace its DNA back to one of these three original projects. System R led to IBM's DB2. Oracle, well, became Oracle. And that academic Ingres project, it spawned a whole dynasty of systems, including Sybase, Microsoft SQL Server, and the open-source hero, Postgres. 3. If you need any more proof of how monumental this whole period was, just look at that number. 3 Turing Awards, the Nobel Prize of Computing, were handed out to the heroes of this story. Charles Bachman for his early pioneering work, Edgar Codd for inventing the relational model itself, and Michael Stonebraker for everything he did with Ingres and its successors.
So this 50-year-old idea has had an unbelievable run. But the world today? We're creating data at a scale and a complexity that Codd and his generation could have never imagined. Which brings us to the big question. In this new world of AI and truly massive unstructured big data, is the long reign of the relational model finally coming to an end? And if so, what's the next brilliant idea that's going to define the next 50 years?